problem 12.1, we have an initial stock price of $72 a share. The stock paid a dividend of $1.20 a share, ending stock price of $79 a share, so it went up $7 a share. What's your percent total return, percent R? Percent R is equal to capital gains yield plus dividend yield, P1 minus P0 over P0 plus D1 over P0. Again, I want to use ending price minus beginning price over beginning price for any price changes or price percentage gains or drops in your life, whether that be pricing of products or pricing of stocks. I always want X2 minus X1 over X1. In this case, P1 minus P0 over P0 is terminology our author likes to use. So ending minus beginning over beginning will get you the right increase or decrease in price for any product, for that matter. So percent R in this case, I take 79 minus 72 over 72 will be my capital gains yield, and my dividend yield will be $1.20 over 72 for a total percent return of 11.3889%. And that is your answer to problem number 1. In problem 12.2, we have the same givens as problem 12.1. In this case, we want to find the components of the total return. So calculating this one, the capital gains yield and the dividend yield, and the two of those pieces should add up to 11.3889% that we found in problem 1, which is your total return. So the capital gains yield is P1 minus P0 over P0, or 79 minus 72 over 72, or 7 over 72, and we get 9.7222%. Very nice return on our stock. Our stock price went up, so we're a very happy investor. In addition to that, we get some dividend yield, which is really good news. $1.20 dividend divided by my $72 share price, I get 1.666667%, and that's my dividend yield. So I add the two pieces together, and I should get 11.3889 as I did in problem number 1. So capital gains yield plus dividend yield equals total percent return. There are your answers for problem number 2. In problem 12.3, we have the initial share price of $72 again, but this time the share price goes down at the end of the year to $61 a share. We still have our dividend of $1.20 a share. What's the percent total return now? Same formula, P1 minus P0 over P0 plus D1 over P0. Breaking it down into capital gains yield and dividend yield once again. My ending price is $61 though, minus 71, so I've had a loss of $9 per share. My dividend and dividend yield remains the same, so I get a total return this time of negative 13.6111%. We're not very happy with this year's performance. Broken down into two pieces, I get 61 minus 72 over 72. That gives me a capital gains yield of negative 15.2778%. My dividend yield remains at 1.6667% for my total return of negative 13.6111%. Notice I had a really rough year stock price wise, muted a little bit by the dividend yield of 1.6667%. There are your answers to problem number 3. In problem number 4, we have the purchase of a 6% coupon bond 1 year ago for $920. Today that bond has risen to $940. So I've made a nice $20 gain on that bond. Assuming $1,000 face, what's the total dollar return over the past year? The total nominal return, percent R, and total real return if H is equal to 3%, inflation equal to 3%. So equations I'm going to use, the coupon received is the coupon rate of 6% times the face value of 1,000. Capital gain on this bond is new price minus old price. So I've made a gain, an increased capital gain. Total dollar return is my coupon received plus my capital gain will be my total dollars, and my percent nominal return, percent R, nominal or total return, is equal to P1 minus P0 over P0 plus the capital, plus the C dollars, which is the coupon divided by P0. So coupon only divided by P0. And again, the Fisher effect, 1 plus big R equals 1 plus little r times 1 plus H. Remember that the Fisher effect's big R is R little r, okay? Which includes a real return and an inflationary component. So let's solve. The coupon received is equal to 6% is the coupon rate on $1,000 or $60. So my Coupon I'm going to get each year on this bond is $60. That's part of my total dollar return. The other part of my total dollar return is my capital gain. Now my bond went up from 920 to 940, so P1 is the new price, 940 minus 920, I get a $20 capital gain on this one. My total dollar return then is my $60 of coupon plus $20 of capital gain. I have an $80 total dollar return is the answer to that one. Now what's the rate of return? P1 minus P0 over P0 plus that coupon divided by the original price. So 940 minus 920 over 920 is my capital gain, if you want to call it that, capital gains yield. And my equivalent dividend yield, in this case we might call it the coupon yield, is $60 divided by 920. Add those two pieces together and I get a total nominal return of 8.6957. Again, this is our percent little r. That translates to percent to the big R in the Fisher effect. So I'm going to put 1 plus our little r here, which is our total return of 8.6957, equals 1 plus some real return times 1.03. Now we know from the approximate Fisher effect that my answer should be about 5.6957%. How did I get that so quickly? I just took 3% off of inflation off of my total nominal return. So 8.6957 minus 3 is 5.6957, so my answer should be around 5.6957%. Let's get the exact real return. I take 1 plus 0.086957 divided by 1.03 of inflation, subtract 1, I get 5.5298%. There are your answers to problem number 4. In problem number 12.5, what's the average annual return on large company stocks from 1926 to 2010 according to Ibbotson and Sinquefield? And what are these in nominal returns and in real returns, what they want to know. So I'm going to use the Fisher effect. 1 plus the nominal rate equals 1 plus real times 1 plus inflation. If I want to do the exact Fisher, if I want to do the approximate Fisher first, big R, or nominal return or total return, is equal to little r real return plus h inflation approximately. Notice the approximation sign here. So I look in the table in the book from the Ibbotson and Sinquefield study, and I find that the average annual return for large company stocks was about 11.9%. No need to add up all those years and divide by 84. There's no need to do that because they already did that for you. It's in Sinquefield. It's in the table in the book. 11.9% is my total annual return for large company stocks. Inflation has averaged 3.1% over that same time period. So my approximate Fisher effect is simply 11.9 minus 3.1. So I should get an answer of about 8.8% when it's all said and done. I can calculate the exact Fisher effect using this equation up top here. 1 plus 0.119 equals 1 plus r times 1.031. And I get an exact Fisher effect real return of 8.5354%. My 8.8% approximation not that far off. There you go. There are your answers to problem number 12.5. In problem 12.6, given what's the real return on long-term government bonds and long-term corporate bonds from 1926 to 2010. Again, we're going to use the Fisher effect. 1 plus the nominal rate is 1 plus real times 1 plus h. That's your exact Fisher. And the approximate Fisher is r, big R is equal to approximately little r plus h. We see from the book that from Ibbotson and Sinquefield, the average annual return for long-term government bonds is about 5.9%. And for long-term corporate bonds, about 6.2%. The lesson we can learn from this is when we buy a bond, a corporate or government, we're going to average about 6% over the last 80-some years. Inflation has averaged 3.1%, as we learned in the last problem from Ibbotson and Sinquefield. So the approximate government bond real return, little r, is equal to 5.9 minus 3.1 approximately. And I'm going to get an approximate real return of 2.8% on a government bond. The exact Fisher effect, I take 1 plus the nominal rate of 5.9% divided by 1 plus inflation of 1.031, and I get 2.7158 for the real rate of return. Very close to my 2.8% approximation. I'll take it. Very good estimate. The approximate corporate bond real return is 6.2%, which is the long-term nominal rate average return. minus 3.1 of inflation, and I get an approximate answer of 3.1%. So my approximate real return, my exact real return should be approximately 3.1%. To find the exact Fisher effect on corporate bonds, the real little r, I take 1.062, which is your total nominal, divided by inflation of 1.031 minus 1. I get an answer of 3.0068%, which is very close to my approximation of 3.1%. I'll take it. So again, when you're doing these Fisher effect problems, do the approximate rate in your head, and then you'll know about in the ballpark where your exact answer should be. There, the answers to problem 2.6. In problem 12.7, we're going to calculate the average returns, the variances, and standard deviations for two different stocks, stock X and stock Y. Stock X has 5-year returns of 17%, 22%, 8%, negative 15%, and 10%. And Y is a little more volatile, 23%, 34%, 11%, and minus 32%, and 21%. The average is equal to the summation of all these returns, divided by T observations. 1, 2, 3, 4, 5 observations equals T. The variance is summation of the square deviations divided by T minus 1 observation. So there we're going to divide by 4. T minus 1, small sample. And standard deviation is square root of the variance. So let's get started on this 5-step process, of which there are 6 steps to calculate, to ultimately get to these standard deviations. Step 0. Change all these numbers to decimals. So we're going to work in decimals. Step 0, work in decimals. Then we'll get into the 5 steps, the other 5 steps. First of all, I'm going to calculate the average. The way I do that is sum up all the returns. So I've converted all my returns to decimals. I sum them up, I get 0.42 or 42%, and then I divide by T observations, or 5, to get an average of 0.084. My average for X, stock X, is 0.084. Step number 1, calculate the average. Step number 2, calculate the deviations. The way I get the deviation is I take the actual return minus the average. So I take 0.17 minus 0.084 and get 0.08600. I take 0.22 minus 0.084 and get 0.136. I take 0.08 and minus 0.084 and get negative 0.004. Watch your sign on some of these negatives. Calculate all the deviations in step number 2, and then I see that all the deviations add up to 0. So one way to check your deviations is to make sure they all add up to 0, and mine do. Step number 2, calculate the deviation by taking the actual return minus the average return. Step number 3, square the deviations to remove the negatives. So square them up and add them up. So 0.086 squared is approximately 0.0074. Again, run these out to 6 or 8 decimal places if you want to be extremely accurate on these answers. I only ran them out to 4 places for sake of space on the board here. Square them up. So 0.13600 squared is approximately 0.0185, and so on all the way down. Square the deviations and sum them up in step number 3. Square them up and sum them up. Square them up and add them up, I like to say. Then the variance in step number 4 is the sum of the square deviations, 0.0809, divided by T minus 1 observations, because we have a small sample size. 0.0809 divided by 4, I get a variance of 0.02023. And then to get in step number 5 to calculate the standard deviation, I simply take the square root of the variance. Square root of 0.02023 should be 14.2232%. And the standard deviation and variance are clearly measures of volatility. It tells you which stock is more volatile, X or Y. Same process for X, or as for X for Y. Stock Y, basically I write down the returns in decimals. Step 0, convert everything to decimals. 0.23, 0.34, 0.11, minus 0.32, and 0.21. Don't forget to watch your signs. Step number 1, I calculate the average of these returns. So sum them up, I get 0.57 divided by 5, I get an average of 0.114 is my average. Step number 1, calculate the average. Step number 2, calculate the deviations for Y. The actual return minus the average return. So 0.23 minus 0.114 equals 0.116. 0.34 minus 0.114 is 0.226, and so on down the line. Again, my deviation should add up to 0. Step number 2, calculate the deviations by taking the actual returns minus the average return of 0.114. Step number 3, calculate the deviations squared and add them up. So square the 0.1160 to get 0.0135. Square the 0.2260 to get 0.0511. Square them all up and add them all up to get 0.2621 in step number 3. Step number 4, calculate the variance by taking the sum of the square deviations, 0.2621, divided by t minus 1 or 4 observations. I get a variance of 0.06553 for y. And I look at then my standard deviation, simply the square root of that, square root of 0.06553 is 25.5998%. We can see using these statistics that stock Y, based on their 5-year returns, is much more volatile than stock X. There are your answers to problem number 7. In problem 12.8, we're given large company returns and T-bill returns for 1970 through 1975, and we're asked to find the average returns, the variances, and the standard deviations for these two instruments. Later on, we're also asked to calculate the risk premium and the average return, the variances and standard deviations for the risk premium. I'm going to let you do that yourself. It's pretty easy to do. I'll explain it, and it just repeats this process for a third time. So here are the large company returns pulled right out of the book from the Ibbotson and Sinkfeld study. You can notice that it was quite a volatile time in terms of stock returns, some from very high to very low, very negative, from 1970 to 75. And also your interest rates seem to be fairly high if the T-bills are representative of interest rates at the time. So average, again, summation of the returns divided by T observations, the variance summation of deviation squared divided by T minus 1 observations, and standard deviation simply the square of the variance. So I take all my returns for large company stocks, and I essentially just write them down as decimals. So I took these percentage returns and wrote them down as decimals. I got a total of all these returns of 0.3330, and then divide that by 6 returns, and I get an average of 0.0555. Then once I have the average, in step number 2, I calculate the deviation by taking the actual return minus the average return. So 0.0394 minus 0.0555 is negative 0.0161. 0.1430 minus 0.0555 is 0.0875, and down the line. All my deviations should again add up to 0. Step number 3, I square the deviations to eliminate the negative. So minus 0.0161 squared is 0.00025921. 0.0875 squared is 0.00765625, and so on down the line. I sum up the square deviations. I get 2.2698, 3486. So step number 3. Square them up and add them up. The variance is 0.26983486, which is the sum of square deviations divided by T minus 1 observations. I get a variance of 0.053966972, and I take the square root of that to get the standard deviation. I come up with a standard deviation of 23.2308%. 23.2308% is my standard deviation for the large company stocks. You can see it's very, very high, a very high standard deviation, indication of high volatility during those years. For the treasury bills, again, I just write down these percentages as decimals in step 0, 0.065, 0.0436, 0.0423, and so on down the line. I sum them up and I get a total of all these returns of 0.3624. Divide that by 6 to get my average return of 0.0604. This is my average return for the T-bills, 0.0604. Then I calculate the deviation. So step number 2, after I've calculated the average, I calculate deviation. 0.065 minus 0.0604 is 0.0046. 0.0436 minus 0.0604 is negative 0.0168. Again, get all these deviations, sum them up. They should all add up to 0 if my deviations are correct. Step number 3, square the deviations and sum them up. So 0.0046 squared is 0.00002116. Negative 0.0168 squared is 0.000282224, and so on. Square them up and sum them up. The total is 0.00117040. is the sum of my square deviations. To get the variance, I take the sum of the square deviations, 0.00117040 divided by 5. T minus 1 observations, I get a variance of 0.0023408. And then finally, to get my standard deviation for the T-bills, I take the square root of the variance and I get 1.53%. 1.53% is my standard deviation, which is very low volatility compared to these large company stocks. Now, the final part of the question asks you to do the risk premium. Risk premium is the premium I receive for investing in a risky asset. So what is the risk premium on the large company stocks? I simply just subtract the T-bills, which is the risk-free rate, from the large companies, and create another table just like this. So risk premium will be like a third column where I'll take large company minus T-bill, large company minus T-bill, and so on. Create a third column over here called risk premium. You'll get a whole nother list of percentages. From that, I'm going to turn them into decimals, do the deviation squared, the variance, and the standard deviation. So I'm going to let you try those risk premiums by yourself. You get the risk premium by just taking large company stock minus T-bills. And then the question, can I have a negative risk premium before an investment? No, because investors demand compensation for their higher risk. And is it possible to have a negative risk premium after investment? Yes, if the risk-free rate is very high due to high inflation, or if the nominal rate or total rate on the risky asset is very low. There you go. There are your answers to problem number 8.